Hey guys, Justine here from Compass Tutoring. So in this video, we're going to be looking at graphing hyperbolas. We're going to go through some simple steps you can follow when graphing them. And we can also look at a shortcut, an easy, way to graph these hyperbola functions, provided that you do know what the original graph looks like. So I'll go through the first point. So the first point is your asymptote. So the definition of an asymptote is basically something that the curve approaches. So if you consider a curve that looks like this, so this is defined as an exponential function. So see this part of the curve over here, as x approaches negative infinity, as we move in that direction, the curve approaches 0 from the y direction. So something like that is defined as your asymptote. So with hyperbolas, they all have asymptotes. So the first and most important thing for you to do when graphing a hyperbola is finding an x and a y asymptote. There are two ways in which to do this. You can use the function itself, so you can rearrange the function in such a way for you to recognize what the asymptotes are. Or on the other hand, what you can do is you can find what y approaches as x approaches infinity and negative infinity, so in both directions. So this is your y asymptote. And for the x asymptote, you can look for what x approaches as y approaches infinity and y approaches negative infinity. So those are the asymptotes. So once you know your asymptotes, you can really set up your graph into quadrants. Next is your intercepts. So just like any function, your intercepts are probably your biggest indicators of what your curve looks like. So your x and your y intercepts are probably one of the most important things with any function. And so a hyperbola is no different. Next is your quadrants. So your asymptotes, with hyperbolas, you have an x and a y asymptote. So what it does, it essentially breaks up your Cartesian plane into 4 quadrants. And a hyperbola has 2 branches. So those branches will lie in 2 quadrants. So the 2 quadrants that they will lie in is determined by the coefficient of your x. So if the coefficient of x is positive, then you know that those branches will lie in the first and the third quadrants. But if the coefficient is negative, then they will lie in the second and the fourth quadrants. I'll go through that in an example. And then finally, the graph. So once you have all these important features, the asymptotes, the intercepts, and the quadrants, once you know where they are placed, then you can simply draw the function. Now, an important thing to understand is, if you look down here, understanding the original function, so y equals 1 on x, so this is your hyperbola. So this is your, original hyperbola. Once you understand this hyperbola, and you understand how to transform a curve about the x and y axis, then you can speed up this process. You can honestly graph any hyperbola really, really quickly, within a matter of minutes. But I will show you how to apply both of these methods to the questions that we are going to explore. So the first one is your hyperbola. So y equals 1 on x. This is your most basic, your most simple hyperbola. So I'm going to draw up a set of axes. So the first thing are the asymptotes. So the asymptotes for this curve is y equals 0 and x equals 0. So they look like this. So I'm going to draw them as dotted lines. Now, these you see are going to be along the axis, so they're going to be a bit difficult for you to actually see, but I'll try and make it a bit more distinct. So I'm going to do them in red. So x equals 0 is on this axis over here. So this is your asymptote x equals 0. And then your asymptote y equals 0 is along this line. So basically they lie on the axis. I know that's not perfectly straight, but so this is y equals 0. And we know that this curve has no x and no y intercepts. And because the coefficient of your x is positive, then that means it's going to lie in the first quadrant and the third quadrant. And one other distinguishing feature for this specific curve is the point 1, 1, which lies roughly here. There you go. So this is your original hyperbola. So it's got an asymptote at x equals 0 and y equals 0, it's got two branches, one in the first quadrant, one in the third quadrant, and it's got no x and y intercepts. So knowing this curve, its asymptotes, and its intercepts can allow you to transform any kind of hyperbola. Okay, so we move on to the next example. So this reads y equals negative 1 on x. So this is almost identical to the last one. So the things that are the same would be your asymptotes. The reason is because the curve has not shifted in any direction. So the asymptotes are still x equals 0 and y equals 0. But the difference with this one is the coefficient of x you see is negative, which means it won't lie in the first and the third, but rather the branches of this hyperbola will lie in the second and the fourth quadrant. And so another distinguishing point for this curve would be the point -1 and the point 1. So you'd find that somewhere here. Okay. So for this example, first thing we're going to look at are the asymptotes. So the y asymptote remains the same. The reason is because the curve has not moved up and down. So this -2 over here affects only the x coordinates. It only affects the x, it does not affect the y. Therefore, the y asymptote is still 0. So what does it mean for the x asymptote then? So the x asymptote is the value of x which makes the denominator 0. So it's important for you to understand that because we cannot have 0 on the denominator. So we have a look at the denominator and the denominator reads x minus 2. So you can look at this from two directions. So the first direction is, sort of what value of x makes this denominator 0, and the value of 2 makes it 0. So 2 minus 2 is 0, therefore x cannot be 2. So this becomes your asymptote. Now the second direction you can look at this from is the curve is being moved to the right by 2. So this is your initial hyperbola. So if you move this hyperbola to the right, so in this direction by 2 units, that shifts this asymptote 2 units to the right. That's why the new asymptote is x equals 2. So there we go, x equals 2. Next thing we're going to consider is the intercepts, x or y intercepts. So for the y-intercept, x equals 0. So I get y equals 1 over 0 minus 2. I get 1 over -2. So the y-intercept is -0.5. And as for the x-intercept, there is none. It doesn't exist. So the third thing is considering in which quadrant it lies. So the coefficient of this fraction with the x is positive. Therefore, it's going to lie in the first and the third quadrant. So now let's graph it. So the first thing to graph are the asymptotes. So you have a look up here. The asymptote of y is still 0, but the asymptote for x is equal to 2. So we'll put in these asymptotes. So y equals 0 lies on the x-axis. And x equals 2 lies over here. And the next thing we found were the intercepts. So the y-intercept was -0.5. So -0.5, if this is -1 here, -0.5 will lie somewhere here. So that means, and there's obviously no x-intercept. So that means we know that both the branches will lie in the first and the third quadrant. So the first branch will lie over here. So the quadrants, once again, to reiterate the point, are broken up by the asymptotes. They're not broken up by the axes, okay? So this would be one quadrant here, you see, because it's contained within the asymptotes. So the first branch will lie within the first quadrant, and the second branch will lie in the third quadrant. Now, it's important for you to note that it has to pass through this point here, because this is its y-intercept. So it's going to look something like this. There you go. So it approaches x equals 2 from this direction, and it approaches y equals 0 from this direction, which is why it has 2 asymptotes. So there we have it. For that example, the only thing that has changed is the x asymptote. So if you know your original curve, the function that we looked at 2 questions ago, the only difference between that question and this one here is the -2. So once you understand that a -2 means a shift to the right by 2, you can simply draw this function because it looks exactly the same except it's been shifted to the right by 2. But also it's important to note that once you shift it to the right, the branches, the whole curve moves, right? So the y asymptote remains the same because you're not moving up and down, you're only moving up to the right. So the x asymptote changes, but what that also means is this branch over here also moves over. So now it has a y-intercept, but still no x-intercept because you're not shifting it up or down. Alrighty, so we'll look at the next example. So this one is y equals 1 over x minus 4. So we're going to follow through the same steps. So the first is finding the asymptotes. So the y asymptote. So let's look at how this differs from our original function 1 on x. So this reads 1 on x minus 4. So this thing over here affects the y. So this calls for a transformation down by 4 because it's negative and it's 4. So you have to shift your original function 4 units down, okay? So what does it mean for your asymptotes? So the y asymptote now must change. If your y asymptote is originally at 0 and you're moving your whole curve down by 4, it will now exist at -4. So if we look at our original function again, so our original function over here, our y asymptote lies at 0. So if the function now changes by moving it down by 4, it means we take the whole function and shift it down 4 units, which means this asymptote over here must also shift down 4 units. So 0 minus 4 is -4, which is why the y asymptote is now at -4. So what does this mean for our x asymptote? So once again, we have a look at the denominator and we see what value of x makes this 0, and it's still the value of 0. And the reason we also know that is because the curve is only shifting down. It's not shifting left or right, which means that the x is not affected, only the y is affected. So the x is only affected if the number is on the denominator with the x. But if the number has been added to the function separately, then that affects the y. So the y asymptote is -4 and the x asymptote is 0. So now let's consider the intercepts of the curve. So let's consider the y-intercept first. So when x equals 0. So we know that x cannot equal 0 because this will make this function undefined. Therefore, we have no y-intercept. Let's consider our x-intercepts when y equals 0. So I'm going to substitute 0 into y. I get 0 equals 1 on x minus 4. I add 4 to both sides. I get 4 equals 1 on x. And I simply cross multiply to give me x equals 1 on 4. So this is my x-intercept, a quarter. And the third thing is the quadrants. So we have a look at the coefficient of x. It's still positive, it's not negative. Therefore, we know it's going to lie in the first and the third quadrant. And so let's graph it. So the first thing we put in are the asymptotes. So y equals -4 and x equals 0. So now let's consider our intercepts. So there's no y-intercept, but there is an x-intercept at a quarter. So if 1 exists roughly here, then a quarter would be roughly over here. And we know that because the coefficient of x is positive, then it's going to lie in the first and the third quadrant. So here's our first quadrant over here, and it has to pass through this point. So it's going to look like this. And for our third quadrant, so it's going to be approaching -4 from this direction and x equals 0 from this direction. Okay, let's look at the last example. So we have x times y equals 6. So this is a bit of a trick question. So the first thing you have to do in this case is you need to rearrange to make y the subject. So if I divide both sides by x, I get y equals 6 over x. So same rules follow through. The first thing we're going to look at are the asymptotes. So let's consider our y asymptote first. So this differs from our original function because of this 6 on the top here, but it doesn't shift the curve up or down. Therefore, the y asymptote remains the same. Nor does this 6 shift the curve to the left or to the right. So our asymptote for x is still 0. Okay, so let's move on to our intercepts now. So for this kind of curve, there are no x and y intercepts because we know for our original, y equals 1 on x, there are no x and y intercepts. And because we're not shifting this up or down or left or right, it means there are no x-intercepts or y-intercepts still for this function. So there are no intercepts, and we know that the coefficient of x is positive, therefore it's going to lie in the first and the third quadrant. So then you can ask the question, how does this curve differ from this curve? Well, let's find out. So let's draw the asymptotes. So these are our asymptotes, and we know that the curves lie in the first and the third quadrant. So now let's put in an identifying point. So when x equals 1, we get y equals 6. So somewhere like here. So if you recall, with our original function, when x equals 1, y equals 1. So it's going to have a similar trend, but slightly different shape to the curve. So that's the identifying feature between this curve and this curve. So there we have it, graphing hyperbolas. I really, really hope that you understand how to graph them and really just the most important features of graphing a hyperbola. It shouldn't take you more than a few minutes once you know the most identifying and most important parts of graphing a hyperbola. I really hope that helps.